So at this point, I would have already gone over my introduction for the day, my agenda, what our game plan was. I would share the code for the Nearpod so they could open it up and jump on here with me. I would start on slide 2, parts of an expression and keywords. So slide 3, if you jump on slide 3 with me, you'll see the parts of the expression we have already gone over. We have our coefficients, those are in blue. Remember, our coefficients are multipliers that are with our variables. Then we have our variables, which are in red. Now, variables are symbols, letters that represent an unknown quantity. If you have two different variables, so in this example, we have an X and we have a Y, those two variables must equal different numbers. They can't be the same. However, if I had two X's or two Y's, those would have to be the same. So the same letter, same number. Different letters, different numbers. We have our constant over here in green. Remember we talked about the word constant, constantly. What does that mean? How do we translate that to math? So constant is our 9. It's unaffected by variables. It's unaffected by coefficients. It's always going to stay the same. Then we have our terms down here in pink. We have 3 terms in this expression. They are separated by our operations. All right, let's keep going. Slide 4 is asking us to circle the variable. So go ahead on your slide and circle the variable. Once you do that, I want you to send me a chat. What did you circle? What are you identifying as the variable? All right, I am seeing 7x and x come through as two of the, well, really the only answers I'm getting, 7x and 7. No one is picking 39. Good job. So 7 and 7x. Let's go back a slide. Let's go back and do a little review here. So our coefficients are in blue. Our variables are in red. Those are two different parts of the same term. So the variable itself, remember, is that letter, that symbol that represents an unknown quantity. So coming back here, the variable, if you want to change your answer, change the chat that you sent me, go ahead and do that. What is the variable? Go ahead and circle that. All right, excellent. So glad some of you guys caught that. Good. So we're going to circle the variable. In this case, it's the X. Good job. All right, next slide is asking us to circle the constant. Circle the constant. Go ahead and circle the constant on your slide, and then I want you to send me a chat letting me know what you circled. Okay, I'm getting some fabulously correct answers on this one. Good job. How many of you, show of hands, if you would like to admit, it's okay. We just did it before. How many of you are going back and checking our resource slide to help you? A few of you, that's excellent. Always use your resources when available, right? Good. So here I'm going to circle what you guys are telling me, the 39. Yes, that is a circle. Think. All right, next slide. Circle the coefficient. Circle the coefficient. This kind of goes with that first slide we did with the variable and how there's two parts of a term that go together, but they're not the same. So keep that in mind as you are sending me your chat with what you're circling for the coefficient. What are you identifying as the coefficient? Go ahead and circle that, and then send me a chat and let me know what you're picking. Yes, you're right. We are running out of options to pick. So yeah, I know. Like those multiple choice ones where you can narrow it down to the end and you're like, ta-da, gift that keeps on giving. I love it. You guys have done so well. Circle the coefficient. We do have our 7 here. Excellent. Excellent. All right. Any questions so far? Any questions about the terminology, coefficients, variables, constants? Okay. Sure, if you have any questions, you send me a chat and let me know. Or you can raise your hand and I'll answer them too, okay? All right, how many terms does this expression have? So we've been using 7x plus 39. How many terms are we looking at here? How many terms? Go ahead and send me a chat. And then after you send me a chat on your slide, I want you to circle the terms. Circle the terms here. I'm going to see what we're getting. All right. Very good. You guys are doing excellent. We have 39 and 7x. Now, even though this is the coefficient, this is the variable, together they make the term. So not each of those is a term. Together they are the term 7x. So just keep that in mind. There are two terms in this expression separated by the plus sign. All right, are we ready to move on? Okay, next slide. We're going to switch it up a little bit. Remember we talked about words and phrases to map and how when we're working with story problems, sometimes we need to identify which operation we're working with. Some days it'll be, we're multiplying decimals today, we're adding decimals today. Sometimes you're going to get a plethora of problems and you have to go in and identify which operation are we going to be working with. This is where we would use this visual to help decode those problems. Identify those words and phrases that will help us take which operation is best. So let's look at the next slide and see how we can put that to work. All right, so this slide actually has a typo. So let me fix that. It says match each phrase to the expression that it represents. It, double its. So Ms. Jeter is just gonna make this one go away, just like that. Yay. All right, so on the left-hand side, we have our expressions, and on the right-hand side, we have our phrases. Now, I'm going to give you a little heads up here. Look on the left-hand side, we have 1, 2, 3, 4, 5 expressions, and on the right-hand side, we have 1, 2, 3, 4 phrases. That means we have one more expression than phrase, which means we're not going to use each of them. So two of the phrases on the left are there to, or the expressions on the left, excuse me, are meant to keep you on your toes a little bit and see how you do with this decoding. I'm going to give you a few minutes, probably 2.5 minutes, to go through and just match the ones you're feeling comfortable with. Go through, pick out the words in the phrase that tell you which operation that you're thinking of, and then draw a line from one side to the next, matching those expressions with those phrases. I'm going to give you a few minutes, and then we're going to come back together and talk through which ones you've identified, and we're going to see if we can identify the one that's trying to trick us. All right. So my 10 minutes is up already, which is just mind-blowing how quickly it goes. I know it's like the world of teaching, right? You never have enough time to do what you intend on doing. So at this point, I would let them work independently to try to come up with matching the phrases and expressions. Obviously, it's the first one, 8 less than 10, that's going to trip them up a bit with the 8 minus 10 or the 10 minus 8. And we would touch upon the numbers and letters with a variable or with an expression, how they don't always go in order. So even though the 8 comes first in this expression and the 10 comes second, it doesn't mean it's going to be the first one. Then as we go through here, they would practice writing expressions. And then at the end is where I would incorporate some differentiation into this lesson. I have found over the years that this lesson doesn't lend itself to too much differentiation. The students really progress well at this concept. I have found overall, you have those who still like to refer to the chart that I shared, translating words to math. You have some who don't feel like they need to use that chart anymore, but I feel like that chart being available to those who need that resource, that visual, that's usually pretty helpful. So I was gonna have them go into breakout rooms and create and label their own expressions. And then I was also going to have them write their own phrases and matching expressions and have them write one expression with the phrase for each operation. I was going to pair them up just according to really random at this point in time. I wouldn't do any ability grouping for anything like this. I would keep it rather simple. I want to encourage the collaboration and the discussion, but I feel like this lesson lends itself to, it's a nice foundation, but not anything too applicable just yet until we start incorporating the word problems into it. At that point, that's when more differentiation comes in, of course, because once you enter into the realm of word problems and real world examples, you get a lot of the decoding and the reading that goes along with it. So at that point, I would definitely incorporate more likability groups, so I can work in smaller groups as others progress at their own pace. And that would really be it for this one. So thank you.